entire screen here. Okay. Okay, this is the OneNote account. So okay to all. Can you all see? Maybe it's easier. Okay, you all also log in. So actually I have more of my solutions here. Okay, let me get that one. So in case you all want to ask anything, you can go ahead to ask. Okay, let me pull out this. No, what I want is this one. I should pull out is this one. Okay. Okay, now third tutorial, as I already explained to you all the other day. All right, so before we actually go into seeing how, who is the one who upload this? Okay, who is the one who upload this? So is my mic okay? Anybody talking?
Yeah, me.
Who is the one who upload this? No one want to answer me. Still early in the morning, is it? Okay. Anyway, let me not you lah. Okay. Okay, yours is down there. Okay, who is the one? Very shy. Okay, don't want to let me know. Okay, never mind. We look at it. This third tutorial here is actually trying to describe the T flip-flop, how a T flip-flop function. Now, when you are writing, when you are writing this part here, yeah, maybe I didn't know. Therefore, nobody answer me. Okay, let me draw first. So he had done all his homework, so he don't want to join already. Okay, so in this case here, now I don't want to look at this one here first. Later I come back to this. Now, entity T flip-flop here is okay, capital letter, small letter, no problems, can be accepted. Anything VHDL accept, I will accept. So now here is okay, when you are writing this, okay, it will be good. Okay, make this one here in line. Shift this one so that okay, easy for us to see. Okay, so in standard logic, this one out also in. You can put it as a T comma clock in standard logic. Then one shot, okay, I can see from here that okay, there are how many input of the same type. This one also okay. All right. Okay. So output, so correct. Except that okay, arrangement not very nice lah. All right. So here, architecture behave of T flip-flop is okay using declare a signal. Now, suka hati standard logic here, if you want to put standard logic, okay, then you put like that. Also can. This one here is trying to declare the initial value for this wire here, okay? This wire W here initially start from 0. Okay? So it's correct lah. All right, but this one here very clear that I start from 0, okay? Then I have a begin, process, begin. Now, this is CLK. Come to here, become clock. So wrong. So if that part is CLK, here you must use back CLK. All right, otherwise they will tell you, okay, don't know what is all this. Okay, so begin, if CLK is a 1. So this is a level trigger. But if you were to look at a question given to you, here, the clock here, right? They put a triangle here. Indicate to me this is a H trigger. So therefore, these parts here, no. Okay, this is not correct. So we have to use event. So clock, apostrophe, event, and if it clock equals to logic 1. So this one, we use a bracket to indicate actually this is one features only. All right, then only I test. If my T equals to logic 0, then this one, is this correct? Is this correct? This concept? Remember the other day, okay, I told you all the truth table for T flip-flop is like that. I put a T here, I put a Q output here or QN output. So I say 0, 1. Okay, when T is a 0, answer here is not a 0, not a 1, but answer is no change. Okay, when T is a 1, answer is change. Okay, so here you test. If my T equals to 0, then this one. But right, my T equals to 0 the time, my W actually should be remain as W, right? No change, ma. Okay? No change. But in this case here, you got to add in else. Otherwise, you will never get this one here change. Else means that, okay, my T will be a 1. Else, okay, my W will become not W. Okay, my W will become not W. Of course, you can do this one first, then only do this. Either way is all right, as long as the logic is correct. Okay, then only I end if. In this case here, no need to have else if. Right, because only 2 conditions are not this one, then must be this one. Then I end my if, I end my process. Now, this begin of the process, okay, start here. So when you sort of, okay, try to end it at time, you end with this begin. So if you insist that, okay, you want to see that this end process is here, then bring this begin to this side, directly after the process. Okay, then very clear that this end process is actually due to this begin. Okay, after finish my process, I assign whatever is the Q value, whatever is my signal value to the Q output, correct? Okay, and my behave. Okay, this one here logically is wrong. So when come to marking this part here, logical error, okay, you are going to get 0 marks. Okay, next, now we look at this thing that we declare. Now, of course, this is a must. Every time, these two are the must. Now the third line here, do I need to have something here called unsigned? Do I need to sort of open this unsigned library? Do I make use of any unsigned over here? This is not unsigned. This is a logic. Everything that I use is logic. So, of course, okay, you put it in, no problems. You can put in more, also no problems, but it's not necessary. So we don't need this one. Okay to all? Okay. Your button, is it Brian, is it? Okay, your one is here, isn't it? I've seen it just now. Below Adina. A little bit more. Oh, your this one here is okay. Okay. This is the one, is it? Input T. This one also Adin. This is yours. This one? Okay. You want me to look at this? Infer din. Infer in this case here is just a name for the process, isn't it? They call it infer. Remember we said this name for the process is optional. Wait, let me get this thing here. I close this one first. Okay. Okay. So okay, maybe I also look at this Brian one first. Now, whether this is right or wrong here, we look at the question first. Now, my question for this T flip-flop is very simple. Okay, very simple. So I have only one input, 2 input, then 1 output. I didn't include the reset. I didn't include preset also. And also the Q bar, I never include because the circuit, okay, that I am going to generate here don't need to use Q bar. So this is something like a custom made lah, okay, for this purpose only. All right. Alice, Brian, okay, you include something called reset. Okay. you include reset. You say that this is okay, when my reset is higher, when my reset is high, okay, then you say, yeah, this one here is working, okay, in a normal way. This high here, your clock high here is level, okay. This one here is like that. You are talking about this one high, okay. This one here, I dot. We are talking about this one low. So this is level trigger. Is latch rather than flip-flops. Okay. So when preset is low that time, everything not function. Straight away, okay, my Q will be a 0. So asynchronous reset. And reset is higher priority than any of these clock or T inputs. All right. So you actually, okay, change my questions already. You go and put in a reset, and you also put in change this clock from edge trigger to become level trigger. Like I mentioned just now. Now this is a edge trigger. Wow, what is this? HEDGE edge trigger. Because you see this triangle. If I draw my this so-called flip-flops here, I play like that. CLK. Then yes, this is a level trigger. Okay, so logic 1 that time, this whole thing is going to work. But when I put this triangle here, means that, okay, they will only work when they see this one here indicating a rising edge. This event. Okay, clear for this part here. Then next, okay, we just go through very fast. Entity T flip-flop is, yes, can clock T, this one, yep, correct. And I don't think, okay, we need this unsigned, but finish whole thing, then only I can conclude. Architecture, this one is begin, infer, this is a name, name of the process. So maybe I put down here optional. Whether you put, you don't put, is okay. Sometimes in one program, you have more than one process. So if you put, then we know that, the infer process. So we refer to this. All right. So this part here, I say, okay, change to clock, event, and another top. Okay, clock event. Wow, 老师 handwriting. Okay, it's a clock event. Okay, event and clock equal logic 1. So change it to this. Put a bracket. Okay, put a bracket. Then I begin t equals to 1. Then I got this one. What do you think of this concept here? So for this case here, if you start off with t equals to 1, can, no problem. Then you also need a else. Okay, else. Okay. This part here, wow, I make a mistake. I forget to put in something here. Else, okay. Actually, theoretically, you will say else, okay, Q same as Q. So this is the output. You declare Q as output, but there is one, okay, theory or rules, okay, for VHDL is output. This output here cannot appear on the right hand side. So this line is actually a mistake already for VHDL. Logically, it's correct, okay, in our digital, but in VHDL, this is wrong. Okay, this is wrong. So I cannot have both, okay, Q on left, Q on right. So in this case here, I declare a signal. This is what I didn't do just now. You declare a signal. Okay, Sukahati, what is the name of your signal? You can put a signal. All signal you can use, if it's one line, you can use this word temporary. Okay, stand for temporary. Sukahati, okay, I don't force. So let's say I call it temp, then I say, okay, the temp for it is a standard logic. And I want to say, okay, it start from 0. Again, this part here also suka hati, by default it is 0. So I put it in here, temp, then only I begin. Okay. Then I architecture begin process. I need a begin here. So all process you need a begin. Okay. If this one, then this one. Okay. Change all your queue now to temp. Okay. Okay. All change to temp. If you think too troublesome, you just can use a wire to W to represent. All right. Okay, then only I end if end my process already, then I must assign this temp to my output. Okay, then only end my floats here. Okay, to all. Okay, so it's good that you make a mistake now, then you will remember. All right, so this part here, is it Brian? You copy from this this net? Okay, from Google you search. So you are changing my question. Okay, the T flip-flop is custom made. Very simple one. Okay, so this is 3A. Then now we are going to make use of this T flip-flop that we generate to build our circuit. Circuit is this one. Very easy one. All right, so this is a asynchronous ripple counter. So it's a 3-bit, 3-bit ripple counter. So my circuit, I mean the program for this VHDL here, basically I actually describing these circuits only. All right, so look at your one rather than my one, okay. So, okay, this is the one. Okay, so look at Brian one, Adin also got do. So I look at your one first. Okay, then later on look at the Adin one, Okay, so now this library here, yeah, just now forgot about this unsigned. I also don't need this unsigned here. Okay, I don't need this one here. Like I say, okay, when they compile the time, no problems. They will say that this one here got no error, but it's really not necessary. Okay, so pen, so I don't need this one. Okay, we look at this one here. Well, again, I don't think I need this unsigned here. So this is an entity TFF3. You can label any name, no problem. I have a single clock. T is an input, then Q out is output. You are going to have output one by one now. Like I say that this is a counter, isn't it? It will be a counter. It will be good for us, okay, to see the output, okay, one shot. So this part here, question first, All right, then I end the part. Okay, architecture, this one is begin. I suppose I need some signal here. Because when come to structural model, okay, I definitely require some wire signal. Okay, how many? Don't know yet. Okay, so I think I put here so that I got enough space to write later. All right, so begin, infer, no problems. Process clock begin. This clock event, this one, then you only talk about Q1. And if Q0 is a 1, then you say this one. Again, you never declare this one as a signal. And what is a Q1? Not defined. Okay. Next, what is Q2? Also not defined as whether it's a signal or whether it is an output. So this part here, a lot of errors. And we are not checking actually this one alone. Okay, so Brian, this one also copy from net, or you write on your own? Brian? Okay, so this program a lot of problems. I don't want to look at it. Okay, we look at a more lesser error one. So you need to call out the component. Yeah, this one looks more appropriate. Okay, looks more appropriate. 100% wrong, but I try only. Okay, very no confidence. Okay, so it's the one entity T flip flop. It don't call it entity T flip flop anymore because the top one is the name as entity T flip flops already. So this one here change the name to maybe Ripple counter. Ripple CNT stand for my counter. I got an input, I got a clock. I have this one here, standard logic vector. He want to put it 0 to 2. I accept. Okay. Then this one here, change the name to Ripple counter. Okay. This one change the name here to Ripple counter. So he's using a signal W. Also, he want to take 0 to 2. I accept also. Okay, then now he called out the component. So the component that he called out should be having the name of a TFF, okay, which is this name. You are calling out this component. Okay, so you called out this component TFF is. And you just copy this part here. Copy the interface of TFF. So what I mean by copy the interface here is I normally do if I'm doing typing, I just copy this one, bulat bulat. Okay, copy, then I paste it here. Okay, the end component, end if the end, the name of the TP flop here, I change it to end component. That's it. Then I am actually using the same component 3 times. I need to call out only 1 time. So not necessarily for this. Okay. So after that, now I need to describe the circuit, not this way. Okay, I describe the circuit connection. Let me have this part here. Let me copy down this thing and put it in. Copy, new. Okay, put at the side here. Okay, class, can you all see? Because I call my earlier, okay, the T flip flop as a TFF lah. All right. So I call out this component. This one I just copy bulat bulat copy bulat bulat, and then I end the component instead of end T flip flop. Okay, done. The next thing I need is declare some signal. So when I declare this signal, that time I try to make it same name as close as possible to the circuit given. Otherwise, later on, I myself will confuse. Hey, this wire where represent which wire and so on. So very difficult to describe. So I try to name it according to the circuit. So by saying so, maybe I also copy down this circuit into these parts here. Okay. So I put it here. So I can refer to the circuit, okay? Then I name it accordingly. Now, I sort of, name my this wire here, making use of this name. So this is the name of my wire. 1, okay, my Q0, Q1, Q2. This one here also, okay, my okay, this is directly connect, directly connect standard T. Okay, so take these three first. So you find that, okay, I declare my signal here, Q0, Q1, Q2, actually are the three that I marked just now. Okay, signal T, hold on first. I declare this signal, standard logic. Like I say, Sukahati, you can put in logic 0. But in this case here, you are going to say individual bit, so logic 0. Okay, now here, I describe the circuit. So you find that I don't put in the clock anymore. I begin to tell you how the circuit look like. This is a structural model, okay? So I begin, I say, okay, T flip-flop 1, T flip-flop 1 means it's this one. Oh, I got a little bit of problems. Okay, so sorry, okay, change it to 0, 1. I forget to change it here, okay? So name it according to this one easier, okay? TFF1, TFF2, TFF3, okay? I name it, okay? And this TFF1 here, actually, what type, how it behave, making use of this component TFF. So I put here TFF, okay? TFF. Then I pop map this one. Means that I do the mapping. I say that first T, you connect to a logic 1. Second one, of course, you connect to the clock. Okay. The third one, position is Q output. I make it connect to a wire labeled as Q0. Now, if you don't like it, you can use T to replace the 1. But here, very straight, I just use, okay, logic 1. That means that this input T here, you connect to a logic 1. And same thing for the second flip-flops, which we label as T flip-flop 1 here, this one. You find that the input is also connected to a logic 1. Okay, then I tell you, okay, you connect to a logic 1. Second one is a clock, isn't it? Clock, now you see it, okay? This Q0, same wire, I make it connect to my input of the clock. This wire, I make it connect to the input of the clock. Okay, then you find that it is connected to this part. They are connected by this name. This output here now becomes the input to my TFF1. And the output of this TFF1 here, you now connect to another wire called Q1. So this Q1 later on, okay, will become the clock input of TFF2. Okay, so same thing, I describe the connection. This one here, I describe the connection, so do the port mapping. So T connect to logic 1, okay, then this one connect to Q2. I think I missed out something, never mind, I add in afterwards. Okay, so after doing all this already, this original entity here, I take the output here, label the output here as count. Like say this is a counter. There's no meaning at all if I look at the output bit by bit. So I lump everything together. I try to see them 3 bit at one shot. So I call it as count. So this count now, okay, I have to tell you that I actually, okay, concatenate these 3 together. So Q2 is the MSB. So this Q2 will be connected to the 2 here. Okay, follow the sequence is Q2 go to the 2, Q0 go to this one. Of course, you may say that what happens in this case here, the ballet really, never mind, we are testing the logic, okay, testing you, okay, the VHDL logic. Okay, so you know how to write this. So I'm converting this or combining these 3 individual bits, okay, individual 1 bit only, combine them or concatenate them to form a 3-bit output. So I do it this way. This is my output. After doing this, okay, then only I end, which I think I cut the time, okay, miss out this. I end my this architecture. The name for it is structure. Okay. So remember, when you are talking about structural, you only describe the circuit. You no need to put in the process already. Okay, the process is inside here, this component, the TFF already. Okay, any questions? Waiting for some question. You must describe this. Say again. Yes, if it's a structural model. If you want to use a component, then you must tell this component, the input pin connect to where, the output pin connect to where. Understand or not? Yes. This is, you tell the connection, no? So of course, if you are not doing this structural model, but behavioral model, then you don't do it this way. I got another question, which is on the behavioral model of describing the counter, isn't it? So then you don't do this way. But this question say, if you read the question carefully, now write this VHDL code for a rising edge T flip-flop shown in figure 1A, this one. Then based on T flip-flop in figure 1A, that means that I want to use this one. Ask you to write a VHDL code for a 3-bit ripple counter. Okay, based on this one, write a 3-bit ripple counter. So structural model already. Okay, and then give you the schematic circuit. Don't expect you to go and imagine. Okay, the schematic circuit of this ripple counter is this one. So I describe, I make use of this one. Okay, do the connections, then I describe. Okay, then I also see there's another question here. Student asked me why I must have a signal T. Remember here, I can use T to replace 1. So if you don't want to say that directly connect to 1, what happened? Okay, my this counter here, I want to connect it to 0. Then you can make use of this signal T over here. All right, put the signal T to replace this one here. Then every time you want to do the time, you decide, okay, should your signal T be a logic 1 or should your signal T be a logic 1? Logic 0. So you have maybe extra lines over here. Okay, am I answer the question? Okay, any more questions on this part? Well, at least you all try, So if no questions here, I also see that, okay, under, wait, tutorial 3, question 1A and 1B. Same thing, okay, Zheng Wai, okay, who is the one who do it, okay, now, I think, okay, this part here should be all right. Okay, okay, this part here is all right. Okay, so what is not all right is here. Begin process, begin. All right, if this one, okay, T this one, okay, because I declare a signal. So this one don't use else if, use else. Okay, no need else if, because if you got else if means more than one option. So, all right, so we use else, then this one, and if, and process, this one. Okay, so another thing I want to bring out is, okay, this process here, maybe we in them a little bit, make it dalam a little bit, so that, okay, this one here is more easy to see. And in this case here, the if also lagi dalam sikit. Okay, more dalam than the process. Then you have your, no, very, very clear that, okay, this if should be this one. So because writing sometimes are difficult to sort of see clearly. So this writing, this if should end with this if. Then this one, if you dalam this one, your if will start here. So this one, no, you make it, okay, same line, in line. So, okay, then this one in line with the begin. This one in line with the architecture. Okay, Zhengwai? I look at your question 2. Just now I was seen it, okay, similar error. All right, change it to this one. And in your case here, you never declare unsigned. Okay, good. So this one here, you want to use Q bar, so you just add in extra this Q bar here. So if you are using extra Q bar, yes. All right, we do it, okay? This is the inverse of it. Okay, so you still only use one wire rather than 2. Okay, so this is the one. Okay, so far, this is a third question. I will consider it as done. Then now, shall we look at question number 4? Now, tutorial number 4. Any questions that anybody want to bring up before we proceed to tutorial 4? Is Adin here already? Cannot see. Is Adin here already? Tak ada. Okay. Okay, nobody want to ask anything, so I hope it is clear to you all. Then later on, okay, the question 2 of tutorial 4 can try out making use of structural model again. Okay, so question number 1, is it Adin is the one who do this part? Okay, now before comment, okay, whether this is right or wrong, we have to look at the question first. Questions say, okay, for these are 4 here. 4. Oh, I didn't put it down. Well, I thought it's very easy, okay. Yep, I didn't put it down. Okay, this is a tutorial solution. So let's go for my questions. Tutorial VHDL. Copy this one. Remember what you have done in the lab for the case of segment. This part. Okay, this one. Okay, so why I want to copy this one here, because this question here say, I expect you all to write a VHDL code for this BCD to a 7 segment, okay, segment code converter. The truth table for this code is as shown. No need to remember, just copy whatever combinations here. You are expected to use process and case statement. Okay, Of course, there are many ways you can do it, but I want you all to go for the easiest way. That is the process and case statement. Okay, I didn't using the if else statement and very long. Okay, and I have to confirm one by one whether this is correct or not. All right, I have to confirm this. So why I want to go for this long method? And also question which hints me that use the process and case statement. So this part here cannot be accepted because he didn't use the method that I described. Okay, or the method that I want. Okay, and I also don't need the unsigned. All these are logic. Okay, so okay, let's say we take this entity, follow the name here, entity convert is. Okay, so he used, okay, A is a standard logic, B standard logic, C standard logic. Actually no problems. Okay, no problems. So my Q is out standard logic. Wow, apa ini? Standard logic vector. Okay, 6 down to 0. All right, and the convert. Okay, architecture float of convert is suka hati. You want to put this name, I got no objection, but this part cannot. Okay, so any idea how we are going to do this part here? We'll look at this one that we have in our lab practical, the segment 2233 segment. When I explained also, I did mention that, okay, very similar to the lab manual segment, right? This is the one. So in the this convert there, under this convert that I'm showing you, there's no H or clock input. There's no clock input. So what I need basically, okay, very similar to it is here. Maybe I copy to wait, I copy here, later on I convert, okay? Other than I type out, my typing is really like very hopeless like that. Okay, so I just copy down this one. First, I change it over here. So I don't need this one anymore. Now, in my, okay, I can also put it into here. Wait, where should I do? So can I put it here? Or maybe here, don't want to model it. This is a type. Okay, maybe I can put here. Then I modify from here. Yeah, all right. Then I didn't want it. Oh, I didn't want it at the bottom. Okay, so can eat the balik undo. This cursor. Okay, cursor no more. Okay. Okay, this is what I want. I don't want to delete this part here. Now, in my list architecture here, well, the name, okay, suka hati, whatever name you use, okay, then you just change accordingly later on, okay? So architecture begin, process. So you are going to find that, okay, my this process here, let's say, okay, I make it depends on my 3 inputs. The 3 input that I'm having here is the A. I don't want to modify too much. My A, my B, my C. Which is labeled here as this part. ABC. So I put here the ABC, okay? Begin. There's no clock control in this case. All right. So therefore, I just sort of, okay, no need to have the clock. So I begin. Okay. So after begin that time, you are going to find that case is normally 1. Instead of put A, comma B, comma C, cannot. So what am I going to do is I'm going to combine this A, B, C here. Okay. Combine it, making use of this something called my concatenate. Apa ini? So this is undo. So okay. So give it a name. Okay. Give it a name. So let's say I call it as my use the word let's say I put down the name here. Did I put down the name here? Okay, well, easy. I put it as ABC. Okay, I'm going to tell you here, these are ABC here, making use it, okay, from A, I concatenate to B, I concatenate to my C. Okay, I concatenate them. So this one here then now become 3-bit. And of course, when I do this, okay, I must declare this one. This is not my input, okay, not my output. So I got to declare it as a signal. So my signal ABC, okay, is taken as a standard logic GIC vector. Okay, and let's say standard logic vector, I think good enough lah. Don't want to make it too long. Okay, ABC is standard logic vector. Then you are going to find that now I check my standard logic vector here. Put it here as a ABC. Because for the case, okay, and process statement, this part here is only 1. So when this ABC here is follow, okay, the table that given. Don't think too much, okay? They start off with 111. I also start off with 111, okay? So here, I convert this one here to 111. And because, okay, this is a vector, okay? Suka hati, you want to change this name to segment out, or in this case here, depends on the name that Adin is using. If he's using Q, okay, I follow this name here as Q. Okay, Q. Out is, okay, is it 111? Is it correct? Label here, the balik. So change this one to. Right, I basically just copy. Okay, and of course this part is not proper anymore. Right, then I copy, okay, again the second condition, which is 110. And this one here, change it to Q. And Q now is given as 10040. Okay, 100. 100. Then 4. 1, 2, 3, 4. Okay, and of course, whether this one here is representing 1 or 2, none of my business. Okay, so I am just trying to mimic whatever table given to me. That's okay. And you all do the changes accordingly. Okay, so after finish all, okay, this is 110. After finish all, okay, always add in the one when others, okay, suka hati, what do you want to put for this one here? Again, let's say I put something here like my Q is a error, okay, label something like a E like that lah. All right, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I need 8. Do you all know what am I talking about? I think one may be correct, okay, if my question never say that use use process and case statement. Okay. If my question never say, then correct. Since, okay, question insists that you must follow this method, okay, so use this method. Now, what is the beauty of using this method here? If you make any error occur at the output, you find that, okay, it is very easy to detect the error. You just check, is my input this one? Is my output this one? Just like that. Or is this input wrong already? Or because A is wrong, because B is wrong, things like that. All right. Ask any question? Then 011, 011, 010. Next is 001. Okay, this one here is all 0. Okay, so only thing I haven't changed is this part. Any question from you all? So if you are using case, you must end the case. All right, but this part here, because we modified, there's no, I didn't use any if, so I delete this end if. All right, so my end process here is this one. So now you find that, okay, your Q straight away, because my Q is straight away here already. So you find that, okay, I no need to define what is the Q condition. Straight away end process and my this architecture, which I label it as behavioral. Okay, so if you are using standard logic, okay, always, okay, good, okay, to include one, which is when others, just in case for any other combinations, okay, which are unexpected, something like an error occur lah. So they will categorize all under this when others. Then you see, oh, how come the display is like that? Oh, possible some of the connection is no good. Okay, therefore I got this error. Okay, makes sense to all. Any questions, class? Oh, this one Brian one never mind, good try Never mind, we all learn together. Don't worry, okay, if I comment anything, okay? So maybe now Brian give you this homework, help me to modify this part. Okay, go according to the question given. All right. Okay, any questions before we proceed? Oh. Hi, the rest, okay, do you all do your homework or not? So today I only see Adin's, Brian, and Chen Wai's homework. What about the rest? Yin Xuan, Kok Wing? Nobody point out that I make a mistake here. Standard logic vector. Nobody point out this. 2 down to 0. So this one, when you have anything vector, must declare the length. Down to is one word. Okay? It's one word. Although in word side, it tell me it's an error, but in VHDL, it is one word. Okay, Yin Xuan, try. QT4 didn't do. John, you did the questions. So must try. In the exam, there's one question. And this coming exam is physical exam. So you must memorize the syntax. No more open book. I'm actually a little bit worried, okay? The students, okay, after open book for almost, okay, 3 semesters, now physical exam, will the failure rate, okay, become very, very high, oh. Of course, the students all prefer open book, Students all prefer open book. Then come to open book, okay, they score very well, okay, B and above. But come to exam, C also cannot dapat. Huh? Getting a C also problems, okay? I tell you, okay, continue open book like this, so next time when you go out, your brain actually is empty, you know. You don't remember anything. Okay, any questions on this? So, Brian helped me to change all these, modify these, So of course, okay, if there's any error here, don't just point out lah. So just accept it. So here we are telling you the concept, Okay, so we now this is question 4, first part, right? Okay. Now question 4, 1 and 4. Okay, we have 1 and 4 here. So we looked at question number 4. Number 4 is talking about T flip-flops. So this is question 4, number 3. Okay, question 4, number 2, nobody have done it yet. If the label here is correct. So anyway, try it, okay? And part A is writing for D flip-flop. Part B is structural model again. Very similar to the questions that we have in tutorial 3, part 2. But then, okay, here they use extra gates. So let's see what is the answer that I'm going to get from you. All right. So other than I tell you everything. Okay, so this one here, this part. Okay, let me go and look for question. Okay, so this is question 3. Okay, look at question 3 first for tutorial 4. Okay. Let's look at the question because this part here got no questions. 1. This is 2. Try out structural model. In your assignment also, you need this structural model for the last part, last questions. Means you have already write component, different components. When you are going to build a circuit at time, you need to use a structural model. All right. So that is your assignment. Okay. Now we look at this third question is here. So in this third question here, ask you to write a VHDL code that represents a 4-bit synchronous counter using if-then-else statement. Okay, so behavioral model. If-then-else statement. The functionality of the 4-bit counter is as follows. So describe to you how this counter here work or the behavior of this counter, this part here. Says that, okay, if my clear is a 1, then the counter is clear. So it's a active high clear. Okay, and this clear here is asynchronous, telling you that clear is of higher priority as compared to my clock. Okay, first line, Second line says that otherwise, okay, if my clear is a 0, then my counter will be incremented by 1 at the rising edge of clock. So it's a rising edge counter if my clear is a 0. So this is the first part. Right. So cut this one here, put it in there and remind us that this is a condition that I meet. Okay, maybe I insert first. Okay, so we remember the conditions. Okay, now let's check here. Library IEEE, this one here, unsigned, maybe yes, I need. All right, entity counter is okay. So my counter here got, okay, who is the one who wrote this? Who is the one who do this? Brian again. Brian again. Okay, Brian, where is the output? All right, so my counter here got a clear, got a clock, but no output. So I don't know what is this one here for lah. Okay, what is the name of the counter that you want to label? Brian? You want to put Q, Q, the one, okay, so maybe we use the word count. Is it okay? Okay, so count here, out, standard logic. And this counter here, how many bits? 4 bit, isn't it? Question say 4 bit, right? So out, standard, yep, standard logic, vector, 3 down to 0. Okay, now here got open bracket. I need another close bracket. This close bracket is for this one. All right, then only semicolon. Okay, then my architecture flow of count is, now since I know this is a counter, that is to say that, okay, I must know what is happening or what is the count just now, then only I can tell you of the new count, isn't it? So in this case, since you are using W here, so I declare a signal here, W, okay? So signal use W, and this signal here is the standard logic vector also. Yeah. If you want to declare 0, can 1, 2, 3, 4. Optional, this part suka hati. Okay, then only I begin. What is this? Okay, now I know that this counter depends on clock. And every time when clock change, I need to do the counting. But even though sometimes the clock change, but my clear is a logic one, then you are going to find that they won't change or they won't increase the count. So therefore, my this process here, okay, inside this process here got two sensitivity component. One is the clear, use CLR, I follow. The other one using clock, CLK. Okay, process depends on these two. Then only I begin. Every process must follow by a begin, process begin. Okay, then you say that if my clear equals to a 1, then my W is this one. Is this all right? Now, after all this modification, is this statement here still correct? Anyone want to suggest, okay, what should I write here? Anyone want to suggest what should I write here? Hey class, tutorial, not I do everything. Anyone want to suggest anything? Or is it that you all type out? Anyone want to suggest anything? Oh, Brian? Since you are doing this, okay, you must sort of thought of it, okay, for some time. Brian, any suggestion? Ah, add to the count. No, clear is the one, so we clear the count, isn't it? Ah, so how to clear the count? You want to put here count, or anyone got any suggestion? Just talk. Huh? Anyone? Hey, my W is how many bit? 4 bit. Here is only 1 bit. Oh, yes, 4 bit. So you have used double inverted comma. 1, 2, 3, 4. Remember during the lecture that time, okay, 4 bit or 8 bit still okay lah. I just press 0, 0, 0 8 times or 0, 0, okay, according to the length of the vector. But if it's, let's say, 64 bit, these are things, is there any other way to do it? Or either you write this way or you say, okay, your W is this one. Still remember this? Others? I don't care how many bit that you are using. I just take this one, put it as 1, 0 only. Then I close this one. Okay, semicolon. Either this one or this one. Of course, this is better. Okay. Clear to all? So when my figure is of this condition, my output is always start with 0, starting the time lah. Else, okay, else if, okay, you use else if, okay. So if I'm using else if, okay, just now I didn't check the spelling, ELSIF. Remove the E, else if, okay. Else if, okay, clock event and clock equals to logic 1, yeah, rising age, then my W, I increase it by 1. Okay. Now it will be good, okay, to add in one else over here. Else, what do you think? My W? No change, right? If it's falling edge, because when clock change, this is called clock change. This is also clock change. So when I'm at this condition that time, so I force into the else, then my W here, no change. Okay, my W here, no change. Okay, then only I end this if, okay, and if, and the process. Okay, I need to end process. Then only I end the architecture, in this case here, name as flock. Okay, any comment of these programs here? This is using the behavioral model. I described to you the behavioral. How the circuit, okay, used to build up this model here, sorry, I don't know. And I don't need to know also. Not interested to know also. Okay, so VHDL, you can make use of behavioral model to describe a counter. You can also use a structural model to describe the counter. But if you are using structural model, you need to build the component first. Then reuse those components you have built earlier. Okay? Think about it, okay? Whether you all can accept this or not, and whether any more mistake in these programs here. I'm waiting for someone to point out one mistake. There is one mistake here, which very similar mistake to Brian made just now. Please point out one mistake, okay, of this program. Yes, there's no output in this counter here, okay? I say, that's why I say very similar to the mistake that Brian made. Brian got no output. My this one here also no output. So to rectify this mistake here, after the process, okay, you must say that count, okay? You assign the count, the W. Whatever is a W value, now you put to the count. Okay, always after the process you do this. Then only you end the architecture. Okay, so why? Thank you. So this is the mistake. Students always make this mistake. Design a counter got no output one. Okay, anyone want to ask anything? Now, in this case here, now in this part, is this unsigned necessarily to be in? Is this unsigned necessary to be in? In this case here, maybe yes, okay, because this is a integer. The one here is an integer. Some okay, sometimes okay, some students will take it as 1 plus W logic. Also can be accepted. Okay, so if you are doing this one, then I don't need this library of unsigned. Okay, because I'm using this bit. All right, so you add this logic to it, also they accept. Okay, so we actually write these programs here from based on the info that given on this part here. All right. So you got to follow this. Okay, that is on 3A. 3B so far nobody try. All right, 3B nobody try. So since I already described so much on this part here, maybe I also want you all to try out. Okay, other than I do everything. I got all my answer here already, okay, but then it's not very proper for me to give you everything. Okay, all the answer are available. This one also available. All right, available. But you all try out. Try out. Okay, then I try to see now. This is question 3. Okay, look at question 4 now. Okay, question 4 now. This is question 1, question 4. Now, question 4, let's see what the question 1's are. Here, just ask you to write a VHDL code for JK flip-flop. Never say what method, so suka hati. Of course, the easiest way using truth table. Okay, using truth table. I think 4B is doing SR flip-flops. Of course, the easiest way also still use this truth table. Okay, so let's see. Okay, Brian, is it? Brian is the one who do it. Let's see this result here. Now, Brian, are you the one who do this? Yeah, okay, good. Okay, yes. You do what? Repeat. Oh, okay. Okay, you do together lah. You all form like a study group like that lah. Okay, good. So help each another. Okay, let's say now must confirm that this truth table is correct first. When my JK both are at 0, so no change. Okay, no change. J is a 1, output is a 1, set the output. K is a 1, reset or clear the output. When 1 function like a T flip-flop, they toggle. All right, so this truth table is correct. So we are going to write based on this truth table here. So in this part here, I don't think I need this. Okay, so we don't open up this library. So entity JK flip-flop is JKQ. Okay, individual bit, 1, 2, 3. Okay, so this part take it correct first. Then architecture flop of this one is I begin. Let's check. J is a 1, K is a 0. So this is a set. So this is called set condition. Yes. Else, this is a reset condition or clear condition. So correct. Else if this one equals to this one, Q equal to this one, also correct. But my question now is, okay, if J equals to 0 and K equals to 0 that time, what should I do? No change, but how come not included? No. So here, last, we add in a else. Else, okay, logically, else Q is the same as Q, the N, isn't it? Okay, this is the one exactly we follow the truth table. But now relate it back to VHDL. Is this correct? Cannot, isn't it? So we add in here. So I need to write something here, okay? The something is the signal. Okay, what is the name of the signal that you want? Temp, you say temp, standard logic, dot 0, okay, 1 bit, so temp. So therefore, if you say this temp, so please change all this. Okay, so change all these to temp. Change all Q. I just write here, change all Q that I mark here to temp. Okay. After this, okay, so like I said, this one here is describing the truth table just now. So my list truth table will only be valid, okay, if I got a clock that control the flip-flop. So in these programs here, there's no such thing as a clock over here. So how should I modify now? How should I Yes. So over here, I add in a clock. So therefore, this tick got to read. So I put it here, same line lah. So I don't need to write so much. So clock is also in standard logic. So this one here got the signal already begin. Blue color. Correct. So I put a process. So very simple JK flip-flop. There's no clear, nothing. Question never say got clear, Okay, so I put something very simple, CLK only. Then I begin this process. Okay, after that, so since I got this process here, else I end if. So here, I need to end the process. Okay, I didn't put a name for this process, so I end the process. After end the process, what else am I supposed to do? Remember just now? What should I do here? The queue, yes. Otherwise, okay, again, no output. So I assign my temp. Whatever is my temp value that I obtain, okay, for this process here, now will be assigned to the queue. Then only I end the flop. Is that okay? Oh, yes, you are right. Yes, thank you. If, okay. Thank you. I miss out this one, clock event. And Now you all can key this one into the quarters 2, okay? And check any more errors. Clock event and clock equals to logic 1. Okay, then followed by if, okay? So because of this if here, I need one more and if, okay? One more and if to end this if. Okay, so I need a one more and if. Okay, because of this if, I need one more and if. So if you have and if, semicolon. So sometimes when we type in VHDL, the moment I saw this if here, I straight away type and if first, then in the middle I filled up. So with that, okay, I won't miss out, okay, any if that I forget to end. Okay, I type this if also, I start off with, okay, another line here, and if, then I fill up the middle, okay, whatever conditions that I need to check. Especially when long program comes, sometimes I have forgotten too many and if already. Okay, any questions on this part? That is on question 4. On this is on the JK flip-flop. SR flip-flop. This one here is can change then. You see, I don't want to explain, okay, in details of this, okay. I write these programs here based on the truth table only. All right. So now the SR flip-flop also, I will do the same thing. Let's confirm that this truth table is correct. Okay, so you are going to find that, okay, I don't want to look at this one. Okay, I just look at this because this is always terbalik, okay? How come this is a 0? This one should be invalid, okay? This one here, invalid. Okay, invalid. Invalid in this case here, normally we put X. But in VHDL is something called don't care terms. Okay, so this input here, we are going to put a don't care terms to it. Okay, let's check here. When this is a condition, set. When this is a condition, how come this is 1? I suppose I should put here as no change. Because here described as after S is a 1 and R is a 0 after this condition, so no change. Okay, so no change. Then this is 0, 1, reset. 0, 0. Okay, 0, 0 also categorized as no change. Because this is after S equals to 0, R equals to 1, so no change. Okay, and 1, 1. You are not supposed to have the conditions of 1, 1 for the case of SR at the same time. Because S actually stand for set, R is a reset. Okay, so you cannot have set and reset at the same time. Therefore, result come up, actually, I'm not sure. Sometimes they give you a 0. Sometimes they give you a 1. Actually, it depends internally whether they are using NOR gate or using NAND gate. So in this case here, result is very uncertain. Okay, so we say don't care or invalid. Okay, so in VHDL, don't care. You use a dash to represent. All right, so based on this concept here, you find out, okay, we actually cover all the combinations already. So we cover 0, 0, we cover 0, 1, 1, 0, and 1, 1. Then based on this understanding, we are going to write out. So of course, okay, try to find out here first. So my again, I don't think I need this unsigned here. You want to call SR flip-flop? Yes. So your port, you got S. So this one here, ARER. What is ARER here? And here I don't see any ARER there. I think it's R lah, huh? Okay, I think it's R only, huh? Okay. Okay. Then one more thing that I need is a clock because this is a flip-flop. Okay, and you have an output called Q. This is a flip-flop, so you must add in the clock by yourself. Then you end this JK flip-flop. Architecture of this one is okay because you have something here called don't care. Sorry, unchanged. Okay, no change. So you find that this part here definitely you need signal. Okay. I will take the signal same name lah. Don't want to think too much. Okay, it's a temp. Then the logic. Okay. After this temp here, I begin because this is a flip-flop, so I must have a process. This process here depends on my clock. Okay. Some students may ask, okay, can I put in the S and R lah? What do you think? Well, S and R are also the input. What do you think? Do I need to put in the S and R here? Or just now that one, do I need to put in the JK? Any suggestions? Do I need to put in the S and R? Actually, in quarters 2, if you put in this S and R, they check the syntax for you, the time, no error. But it will slow down the whole process. So slow down in the sense that, okay, when S change and R change, my clock never change. Only S or R change, they also run this one. But you are going to find that, okay, useless, okay? Because clock is the one who control, okay, the whole flip-flops here. So therefore, we don't put, okay, the S or the R into this sensitivity list. In the exam, you put, okay, actually it's no error, but I minus your mark. Program not good enough. Okay, so in our case here, process only depends on the clock. Then I begin this process. Okay, first thing I check, okay, is the, anyone want to say? Adin, are you talking? Adin sound like a very far away. Okay, if clock event and clock, okay, we check the clock conditions. Question actually never say is a rising edge or falling edge. So in this case here, you put a 0, it's okay. Because question never say. All right, I purposely want to put here as a 0 lah, so that to tell you here, this is a falling edge. Question never say. So I suka hati, as long as, okay, I indicate to you that this is a flip-flops. Okay, it's a edge trigger flip-flops. Then, okay, if this is the case, then this one. Okay, I add in here. So of course, okay, later on, I need to put end this process and end this if lah. So that one is later. Then now I check. If my S is 1, and my R is a 0, this is 1, 0, okay? So this one here, we change this one here to a temp. If S is a 0, R is a 1, so this is a reset temp. Okay. else if. Okay, else if what conditions? I already consider 1, 0, 1, 0. Else if, okay, maybe I check, okay, s equals to a 0, whatever not mentioned here. This one, 0. Then, what is your temp? This one here, what is the temp? Huh? Not yet. Not yet. One more. Then only we put else. This is only 1, 2, 3. One more condition. No change. Then can I put here back to temp? Okay. Then with this, okay, I else finally then only I put else. Else, okay. In this case here, there's no need to write the conditions anymore. All right. So you should always say your temp equals to what? Invalid. Don't care. This is a don't care in VHDL. Okay. Then only I end my if. After I end my if, end process. Sorry, not end process. End this if first. Okay. End if. So maybe here describe a bit for the clock. Okay. This if is for the clock. Then only I end the process. Okay. After end the process, don't forget about your output. There's no output. So I assign the temp to my output. Then only I end my flow. Okay. What about the rest? Okay, are you all right? Okay. So there are many ways to write it, okay? So suka hati, you arrange it as long as you arrange it correctly. So I can use variable also instead of signal. Can? Okay, you can concatenate the S and R, then you will just say that, okay, say when 10 you declare as 2-bit. So if 10 equals to 10, you can use a case statement to do it also. But this question never say use case statements. If you use case statement, it's correct. I just want a SR flip-flop or JK flip-flop. Any method you use, accepted. Marian, you can try. Use case statement. Concatenate your SR and concatenate your JK. Try already. You already tried? Oh, okay. I thought you already tried, then I asked you to upload. I think it's talking, but very soft that I cannot hear clearly. I think. Are you asking a question just now? Who beside you? Oh, okay. But sound like Adin. Okay. So no other person who asked a question, is it? So can sort of key this one, okay, in the quarters too. Then you get yourself familiar with the syntax. So over here, I write sometimes, okay, I may miss out, okay, the semicolon, things like that. As I talk, sometimes I will miss out, okay. So just add it in, okay, when you are doing your typing. Or you think this one too messy, okay, you type already, you want to put it at the side there, go ahead, upload it. All right. Okay, any questions? Now, I still have a question. I think 2 more questions I haven't do, isn't it? Wait, this one here, I want you to think a bit. This is something to do with shifting. All right, and one more is on this parts here, because I already explained the T flip-flops. This one here is slightly more complex only. Let's see, okay, what is the result that you're going to produce. Okay, well, this one here, we can do it this Friday, this Thursday, no, okay. This Thursday got this physical lab, you want to go back and attend my online class? Yeah, lor. That's why we continue with the physical class, though. We can do it in the lab because the lab I know is nobody is using, and the lab is big enough. Okay, so try out, okay, how to write and describe for 2 more. Okay, tutorial for VHDL for today, good enough? Okay, I hope, okay, it clear many of your questions. So we stop the tutorial for this part here, and then we continue, not really like a lecture, okay, but it's more like a revisions of a combinational circuit. Okay, we take a break. Okay, Lun Chen asks, what if in the exam you don't know the result? What do you mean by you don't know the result? So testing you the logic, whether your logic is correct or just like JK flip-flop, you don't know how JK flip-flop function, is it? In the exam, normally I will set some common components. I'm not testing you of whether you know the component or not. But I'm sure, okay, later on, after you study your sequential circuit, you should know, okay, as an electronic student, you should know how JK flip-flop work. So today, if you say that you've forgotten the table or the behavioral of flip-flop, I can accept, but not after the whole lecture or after, okay, towards the end of this semester here. If you tell me you don't know how JK flip-flop work, I must be very sad, okay? So like I say, okay, I don't really test you something that you don't know. Then come to testing VHDL, I'm testing you on VHDL. Okay. Now, any more question related? Okay, we still have 1 more hour. You all want to continue after this? Okay, so must put clear CLR. Which part must put clear? Now I saw Adin. Which part you want to put clear, Adin? If the question never say, like in this case here, if the question never say, okay, you want to put clear, if the way you put is correct, you are right. But like the third questions, okay, the diagram is being drawn out to you that, okay, third questions, or this part, okay, I think I put it here. Third question, okay, the components have been drawn out, okay, for you to see, then please don't add the clear. This one here is a very custom design for this circuits only. Because I start off this, okay, I don't want to put in a lot of these component, I mean a lot of control pins. So clear how it works first. All right, then come to question number 4.1 that time. 4.1, sorry, not 4.1. 4.4. Then 4.4, no. 4.3, sorry. Remember the wrong thing. Like this one here, then only, okay, put in the clear for you. Okay, put in the clear. So you must check the clear first. Then only check the clock. Because if my clear not changing, stay at, let's say in this example here, stay at 0, my clock change, you must also run these programs, otherwise they will not increase. So these two are actually the control. So it depends on the questions. Of course, you do extra, no problems. You do less, then got problems lah. Your marks, okay, will be cut a bit. I didn't answer your questions. Okay, so we take a 10 minutes break. I talked for 2 hours already, very tired already. So we break for 10 minutes. Okay, come back at 12. Then I tell you where is the lab. Yes, if we continue at 12, okay, our class end at 1 p.m. You got your lunch at 1 p.m. Okay, John? Will you be too hungry? Okay, so take a break. Okay, I stress a little bit, okay, before I continue.